In these notes, we're going to be continuing the work with parallel and perpendicular lines, where in the last notes we just kind of looked at the relationship between the equations of parallel lines and the equations of perpendicular lines, specifically in that the slope of parallel lines is the same and the slope of perpendicular lines is opposite reciprocal. What we're going to be doing today is actually using this information to write the equation of a line if we know a parallel or perpendicular line and a point that the line goes through. So we'll do some examples about that. But then really quick, I do want to just remind everyone that the slopes of parallel lines are the same. So parallel lines have the same slope, and perpendicular lines have opposite reciprocal slopes. Remember, that means flip the slope, so flip the fraction, and then make it the opposite, so positive or negative from what the original slope was. And again, we'll practice this right now, so if you aren't sure about that, you'll see in these examples. So for the first example, we have to write the equation of a line that is parallel to y equals 3x minus 5 through the point negative 1, 2. So we have a point, but remember, to do point slope form, we need the slope as well. Now, since we know that our line is parallel to this one, which has a slope of 3, our line also has a slope of 3. So with that information, we can write the equation in point slope form, which, as a reminder, is this: y minus y1 equals m times x minus x1. So we can just fill in the information that we need there. So y minus the y value is 2, so y minus 2 equals, the slope is 3, which we found out from the problem, times x. Now this is a negative 1 for the x value, so because we would write minus negative 1, we're going to write plus 1 instead. So there is the equation of that line in point slope form. So now we just need to distribute. Don't really want to use that pen. So now we just need to distribute. So now we just need to distribute the 3 here. So we go y minus 2 equals 3x plus 3. We'll add 2 to finish out the problem. So y equals 3x plus 5 is the final equation here. So this is an equation of a line that is parallel to y equals 3x minus 5, but goes through the point negative 1, 2. All right, next question. Parallel to y equals negative 3/4 x plus 2 through the point 16, 4. Again, we know that it is parallel, and this is the slope. So we can be confident that the slope here is negative 3/4. It's the same because it is parallel. So let's fill out our point slope form. Y minus the y value from the point is 4 equals negative 3/4 times x minus the x value is 16, and there is point slope form. Just like the previous problem, we'll distribute the negative 3/4 here. So y minus 4 equals negative 3/4 x. Now to do negative 3/4 times negative 16, just remember to multiply the whole number by the top and then divide by the bottom number of the fraction. So negative 16 times negative 3 and then divided by 4 will give us positive 12. And then we'll add 4 to finish out the problem. So y equals negative 3/4 x plus 16. And there is the equation of the line parallel to negative 3/4 x plus 2 through the point 16, 4. So again, we're using the slope from an equation that we know is parallel or perpendicular, as we'll see next, and using a point that the line goes through to write the equation in point slope form and then solve for y. So example C, which says we have a line that is perpendicular to y equals 3x minus 5 through the point 9, negative 2. Now remember, perpendicular slopes are opposite reciprocals. So the slope here is 3, but the slope of our line will be negative 1 over 3. So flip the number, 3 over 1 becomes 1 over 3, and change the sign. Positive becomes a negative. But now we can fill out point slope form. So y minus, the y value is negative 2, so it'll become plus 2 equals negative 1/3 times x minus 9 is the x value. So distributing the negative 1/3, negative 1/3 x plus 3. 9 times negative 1/3, or negative 9 times negative 1/3, is positive 3. And then we'll subtract 2 to finish the problem. So y equals negative 1/3 x plus 1. 3 plus negative 2, or 3 minus 2, is plus 1. Okay, so again, perpendicular, flip the slope and change the sign. So 3 becomes negative 1/3 for our slope, and then point slope form to get the other part of the equation. Example D, perpendicular again, to y equals 2/3 x plus 8. So again, here's the slope, 2/3. Our slope will become negative 3 over 2. Flip it and change the sign. Through the point, negative 10, 5. So we can now fill out point slope form. Y minus 5, that's the y value, equals negative 3 over 2 times x plus 10 here, because it's negative in the point. Distribute the negative 3 over 2. So y minus 5 equals negative 3 over 2x. 10 times negative 3 is negative 30, divided by 2 is negative 15, so minus 15. Lastly, add 5 to both sides. And y equals negative 3 over 2x minus 10. Okay, so there you have that. Kind of a brief overview of writing an equation that's parallel or perpendicular to a known equation through a certain point. So let's practice this a little further down here. Example E, same type of question. Write the equation of the line parallel to y equals negative 1/2 x plus 2 through the point 8, 4. So since it's parallel, we have the same slope, which is negative 1/2. So point slope form, y minus 4 is the y value here, equals negative 1/2 times x minus 8. Distribute, y minus 4 equals negative 1/2 x plus 4. Negative 1/2 times negative 8 is positive 4. Add 4 to both sides, and y equals negative 1/2 x plus 8. Now, the next example says to graph the original equation from problem E as well as the equation we got as an answer. So we have to graph the original equation, which was y equals negative 1/2 x plus 2, as well as the equation we got for the answer, which was y equals negative 1/2 x plus 8. So first, let's do the original one, negative 1/2 x plus 2. Start at 2 on the y-axis, and the slope is negative 1/2, so down 1, right 2, or up 1, left 2. Let's connect those. And then the other equation that we found for our answer was negative 1/2 x plus 8. Now 8 is significantly up here, it's up through this point, but we can go for it. So slope is negative 1 over 2, so down 1 over 2 is here, then down 1 over 2 would be right here. So do your best with that. I know it's off the graph a bit, but you can try to estimate where those lines are. Are these lines parallel? Yes, they are. So just to confirm that these two equations do give us a pair of parallel lines. Okay, last one. Write the equation of the line perpendicular to y equals negative 1/2 x plus 2 through the point 2, 2. So perpendicular, we're going to take that slope and flip it. So negative 1/2 becomes positive 2 over 1, or positive 2. So point slope form, y minus the y value here is 2 equals 2 is the slope times x minus 2 again. A lot of 2's in this problem. Distribute the 2. So y minus 2 equals 2x minus 4. We'll add 2 to both sides for a final equation of y equals 2x minus 2. Same idea, we're going to graph both of these equations. Y equals negative 1/2 x plus 2 is the original, and then y equals 2x minus 2 is our perpendicular answer for that problem. So first the original equation, which is the same as the previous problem. So starting up at 2 and then slope of negative 1 over 2. Looks like this. Okay, now this slope, or the equation y equals 2x minus 2, we're starting at negative 2 and then up 2 over 1 for the slope, or down 2, left 1. So there's our line that we found. And so the question, are these lines perpendicular? Well, you can see they do meet at a 90-degree angle there. So yes, they are perpendicular, so that confirms that we did those problems correctly. So basic idea, if you know a parallel or perpendicular line, and you know the equation of it, and you also know the point or any point that your line goes through, you can use point slope form to write the equation of that line.